to t, 0 to t. Okay, here you can tell the 2 will cancel out, and we can have s is square root of 2, and then we can have 2 e to t minus 1, because e to the 0 is just 1. That's why we have 1 here. And then we can have, okay, that's s. That's s. Now the question, if you read carefully the question, it says reparameterize, right? So we have to express. We have to express first. Express. You have to express t in terms of s. If you express t in terms of f, you will have a square root of 2 e to the 2t minus 1 is equal to s divided by square root of 2. Okay? I divide both sides by square root of 2. So you don't have to take the square root of 2. So keep moving. So you have e to the 2t minus 1. You don't have to take, you don't have to put the parentheses no more. So e to the 2t is just add both sides by 1. You have s over square root of 2 plus 1. And now take the ln both sides. The e will cancel out. You have 2t, and you take the ln both sides. Ln of 1 plus s over square root of 2. Okay? And now we got the t now in terms of s. Just like I told you. We have t is equal to 1/2. T equal to 1/2 of ln 1 plus s over square root of 2. Okay, we have this one now. Now, the question was, now since we did express t with respect of s, now we have to plug it back in here, the vector function. Replace t, the one we express t with respect of s mean the link, the arc link. Take this one and try to express it with respect of s. Okay, this one. Okay, let me copy it. Okay, you know the vector function is this one. We have to replace t here, and we can express the vector function with respect of s in term of s, sorry, in term of arc length is equal to 1/2 of ln 1 plus. Now s, e. So you have to take the e to the 2, now replace by 1/2 ln 1 plus s over square root of 2. Okay, small bracket here. I just replace that s by this one. Now the t by that expression. Okay, and do the same thing for cos, and do the same thing for sine, and this one. Don't touch here. There is nothing t here. This is just a constant number. So now the cos also will be 2 bracket parenthesis 1/2 ln 1 plus s over square root of 2. Close the bracket. and you have I for now. The next one you have plus 2j, nothing changed, plus e to the 2 bracket 1/2 of ln 1 plus s over square root of 2. And then you have, close it, and then you have sine of 2 times t, and t is 1/2 ln 1 plus s over square root of 2. Okay, and then you have k here, k vector. Okay, let's keep going. The vector function in terms of s is, the 2 will cancel out, by the way. The 2 will cancel out, and you have this one. The 2 will cancel out. You have e to the ln 1 plus s over square root of 2. What do you think this one should be? This one is just, if you have this one is e to the 8, e to the natural log, e to the ln of 8, it's just 8. E to the ln of the backs is just the backs. Okay, so you don't have to write down this one, just write down the expression inside the ln. So because the 2 will cancel out, if the 2 cancel out, you have e to the ln, and then you will have 1 plus s over square root of 2. If anyone didn't understand, ask question, please, and your classmate will be able to help you. If not, just wait until I come back. And you have this one, and you have cos. If you check the cosine, the 2 will cancel out, and you have cosine of ln of 1 plus s over square root of 2. Now you can write down the I. The next is 2j vector, and this one is the same thing. This one is just ln. It's just the expression inside the ln. It's just 1 plus s over square root of 2, and then you have sine. The 2 will cancel out, and you have ln of 1 plus s over square root of 2. That's it. Okay. Now we can factorize by s 1 plus s over square root of 2 parenthesis, and we can put the big bracket, and we can have cosine of ln of 1 plus s over square root of 2 of I plus, oh no, you have to divide it. Okay, we can divide it, that's fine. Plus 2 over 1 plus s over square root of 2. That's fine. And you have j here plus sine of ln of 1 plus s over square root of 2. And you have k. Close it. That's it. That's the meaning here. That's the meaning. Okay? That's it. That's it. Now I think you can do number, let me open the book. Okay. We did number 14. You should be able to do number, okay. I want you to do working group. Working group right now, and stop. Working group, and I want you to do number, you should be able, by the way, you should be able, it's the same process, same tactic. You should be able to do question number 13, number 14, okay, It's the same process, except 16. 16 is different because 16 they give you another point. Now I want you to do this one very quick. Okay. Number 15 you don't have to. No, I already did number 14, but just do number 13 so you can understand the process. Okay, when you're done, let me do number 16. Okay, number 16 is the same thing, but the only difference is now they give you the point. The only difference is they give you the point here. The point is given. Anytime the point is given, mean t equal 1. In our case, you have a 0.01. What does it mean? Mean t equal 1. Okay. Say in the direction of t. Okay. That's the meaning. Rewrite the expression. Okay. That's the it's same process. Same process, by the way. Here, the only difference here, it will go from 1 to t. That's the only difference. But it's the same process. I think it's the same. It's connected. I don't have to do that. 16, I don't have to do that. Let me jump to number 17. Number 17, I think, should be good for you. Let me jump to number 17. And number 17, you already got the solution. Let me jump to number 18. Number 18, they ask you to find the unit tangent and the unit normal vector. You have t and n. Remember, t is a unit tangent vector. Unit tangent vector. And nt is the unit normal vector. Now, that's the first question they ask you, and they give you the vector function. The vector function, you have this. The vector function, you have t to the t square, and you have sine of t minus t cosine of t, and you have cosine of t plus t sine of t, and you have t greater to 0. Okay, they give you this one. So the question was, found the tangent unit. Okay, what's the formula for the unit tangent vector? Remember, the unit tangent vector is, the formula is on the book, is the derivative of the vector function divided by the length of the vector function. So you have to know those kind of formula. Okay, and make sure it's a vector here. It's a vector. A vector divided by his length is still a vector. That's why it's called unit tangent vector. It's a vector. Okay, make sure you write down the r on top. So here now, let's take the derivative. You have r prime of t. You have this one. You will have 2t. Take the derivative this one. You will have cosine of t minus this one. You have cos t. And take the derivative. You have positive t